function on the bottom, and it's all good. Okay. So, what is the? Oh, now I should look and see if I adjusted these or not. I think I did. Oh, nope, I didn't adjust it. Uh-oh, that breaks. Yeah. So, what's the first thing we do? Domain? Domain and vertical asymptotes. Okay? So, how do we do domain and vertical asymptotes?
Look at the domain of the Q of X.
I look at what? And what about the denominator?
You don't want it to equal 0.
Okay, so our denominator cannot equal 0. What do we do next?
Vertical asymptote.
Okay. Part of the denominator being 0. Yeah.
Okay.
So what do we do next? So the next step. Simplify it. Okay. And what are we looking for there? Any common factors, right? Okay. So here we're looking for common factors. Okay, what do we do next? We look for what, Christine? Look at horizontal asymptotes. Okay? What do we look for there?
X probably is greater.
What am I looking at? The degrees.
Yeah.
Okay, yeah. Yeah.
See, you guys know what I'm talking about. You just think it's funny because I can't explain it.
Right. Three choices.
Top grader.
We'll talk about that one later.
Bottom grader.
Bottom greater. What if the bottom is greater?
Y equals 0.
Another option.
Bottom and top equal.
Equal. And then, so what's my horizontal asymptote?
Y equals A over B.
Technically not the same. Uh-huh. And the last one?
Top grader.
Top is greater.
None, but now you have a slant.
But unless they, if they differ by 1, then that's going to be a step 6.
We talked about what if they differ by more than 1 today.
I told you yesterday we're not going to ever graph those.
Oh, well, I didn't catch that part.
Yeah.
I caught it today now.
That's right.
Oh, yeah.
A lot of things that come out of my mouth people don't catch.
I caught like at least 90% of things.
What's the next one? Step 3? Find the int. How are we going to find the int?
0 incorrect.
So we find f of 0 basically. That is actually the same thing. And what's it going to look like? 0 comma something, and it's going to be a point. What do we do next? Find the zint. How do I find the zint?
Set the numerator equal to 0.
What's it going to look like?
Number comma 0.
Logic question. How many points can I get in step number 3?
1.
1 or none, right? Yeah, 1 or none. How many can I get in step number 4?
As many as the degree.
Can I get none?
Or none.
I can get none, and then as many as the
Degree.
of the numerator. Yep. The degree of the numerator, that's how many will tell you that there are in there. Okay, so that one can have multiple in 4, maximum of 1 in 3. Okay. Step number 5. What? Wholes. Okay. How do I find any and all wholes?
Well, it depends if you factored out a term in step 2.
It's step 1.5.
1.5, yes.
Okay. So common factor equal to 0. And then okay. So that's going to be a point, right? Okay. All right. So we set the common factor from step 1.5, if there was one, equal to 0. Solve that, and then put that into our function, and that's going to give us the whole. Okay. Otherwise known as a removable discontinuity. Okay. Next.
Find more points.
Slant asymptote now. Okay. If there's any. So this would be in that degrees differs by 1 case. Okay. How do I find the slant asymptote? So actually, I gotta go back here. Remember P first. So P of X divided by Q of X. Actually, do the division, either synthetically or long. Okay. Then what? What about you remove it? Just throw it out. Okay. Drop the remainder. And then put it y equals mx plus b form. Will I always have a remainder to drop in part B?
Yes.
Yes. Because if I don't,
Then you had a whole.
then there was common factors to remove, and I've done everything above that row. Okay? Alright? Step 7.
Graph. Find more points.
Find more points to graph. And what do we look for? Come on now.
T-charts.
T-charts. And T-charts for where, Nick? In each zone, right? Yeah. And how do we define our zones? Which kind of asymptotes? Verticals. Good job. Okay. Go for it. Step number 1.
Domain.
What is it?
X cannot equal plus or minus 2. And all real numbers.
Do we agree with that?
Sir, yes, sir.
Okay. Can it be factored? Yes, but no. What do you mean, yes, but no? Okay. So it can be factored. So we could factor out a 3 and we'd be left with x plus 3. And we can make that be x minus 2 and x plus 2. Right? So it can be factored, but yet there are no common factors. So we can finish off step number 1 then. What are my vertical asymptotes? Next step. Horizontal asymptote, because we didn't factor anything out. Okay. So HA is y equals 0. Do we all agree with y equals 0 as our horizontal asymptote? Okay. I would agree with that. Next step. What is my int?
Negative 9/4. 0,
So that's like negative 2.25?
Yeah.
Yeah.
Next step. What is my x-intercept?
Wait, why are you putting it there?
Oh, I put it at positive 3, didn't I?
Yeah.
Why are you yelling at me?
No, I just questioned you. I didn't yell.
Okay. Guy can make one mistake, right?
I was just wondering. I was just questioning. I didn't yell. You typed at me.
Okay. Step 5. Holes? None? Step 6.
None.
No saws.
No saw.
Oh, no saw.
Sidebar question.
Sidebar answer.
Can I have a horizontal asymptote and a slant asymptote on the same graph?
No.
Yes or no?
No.
Yes.
No,
Yes.
you can't.
No.
No.
Yes.
No.
Uh-huh.
Nick, no. You can't.
Yeah, I'm confident.
By definition, it's no.
But that's only a definition.
You're right. You are right. You are correct there. That is a definition. Yes. Right?
Really, I could draw one in right there.
You could draw one in.
Yeah.
Yeah. Yeah. Yep. You do have me there.
Well, doesn't a slant asymptote have part of a horizontal asymptote in its component? So kind of yes.
No.
So then if you had them both, that would be a function?
If you had them both, you did something wrong. Yeah.
Yeah.
That's one of those. That's one of those. If you knew you did something wrong, if you get them both. Okay. So we gotta come up with some different points then, right?
Yeah.
So let's go with negative 10. If I go with negative 10, then I've got my function. I'm going to rewrite my function down here. 3x plus 9 over x squared minus 4. So that's going to be negative 21 over 96. That's negative, correct? Yeah? Okay, that's negative. So that means I'm down here on this side. Now, logic tells me that if I end up on that bottom side of my horizontal asymptote and I have an x-intercept in that zone, that I should end up going like this. Right?
Yes.
Because I'm in the negative, out at negative 10, cross the x-axis at -3, and there's not another x-intercept, right? So that tells me it's got to go like that. Now, we should probably test that, though, right? Okay. Well, let's test it with -2.5. -2.5 times 3 is -7.5. Plus 9 is positive 1.5. Yes? Negative 2.5 squared is 6.25. Minus 4 is 2.25. Is that a positive number or is that a negative number?
Positive.
It's going to be positive because it's a positive divided by a positive. So that just proves that we cross over there and go up. Okay? Then I need to go into my middle zone, -1 and +1. -1 is going to be -3 plus 9 is 6, divided by -3, which would then be -2. 1 would be 12 divided by -3, which would be -4. How does what work?
No, but it can't.
There's no x-intercept, so it doesn't cross. Does it? Can it just stop?
No, it's gonna
No,
keep going on
it can
forever.
bounce back down. Right?
So it comes up. Do we agree that it comes up here?
So just that other point is the.
And goes like that, right? Well, but it's not really logic though, because it's not a perfect parabola in there. It's off kilter. You know what I mean? Yes. Yeah.
But then let's say like you plot like I don't want to take just 1 or -1, so I take like -1.75.
Perfect.
And then that's less than
-4.
No,
-4.
-2.
Okay.
Your y-intercept. Then that would, if you're counting your points, you won't hit that 1 up at the top. The graph would come down too soon, and you would never hit that point top.
So long story short, make sure you do 1 and -1 in this case.
Okay.
All right. Good job. Over here, let's do 3. 3 would be 18 over 5. 18 divided by 5 is 3.6. Let's do 4. That would be 21 over 12. That would be a little bit less than 2. And then let's do 10. 39 over 96 would be down there. Then we could do our end behavior and asymptotal behavior, right? Okay. Want to work left to right? Okay. Let's work left to right. So, end behavior over here would be negative infinity. I think it was f of x. What? No. 0 from below?
Yeah, you're saying as it's going to negative infinity, it's getting closer and closer to your horizontal asymptote.
Because what from yesterday and week and a half ago, at the infinities, our function, when we're going to talk and behavior, our function goes to our horizontal asymptote. And our horizontal asymptote in this case is 0. Little bit. Okay. Working left to right, then we'd have up here. Negative 2 from the left. Positive infinity. Then, working left to right, we'd have here. Just going to move that over just a little bit. Oops, now I'm in the wrong color. Negative 2 from the right. F of x goes to negative infinity. Then we've got this one. Two from the left. Negative infinity. Then we've got this one. Two from the right. Positive infinity. Then we've got that one.